Good morning, students. So today in this video, we will be starting with totally a different module of your microbiology class, and this is your antibiotic. Okay. Now, if I ask you, or if I start with this particular antibiotics, you know that you have learned in your previous class. Let's relate the previous class with the present class. That you have learned in your previous class host pathogen interaction, and you know that in this host pathogen interaction, if there is no equilibrium between the host and pathogen, then either the host will survive or the pathogen will survive. Now, if in the battle the pathogen is killed, then the host wins. So how does this host wins? Host wins because of its versatile immune system, and moreover, if it is a bacterial pathogens, right, then with the help of certain chemical molecule, right, that is used to inhibit that particular pathogen, right? So from that point of view, we will be discussing those agents, right, that will inhibit microorganisms. Now, in that respect, we have both antibiotics, and there is a difference, fine difference between antibiotics and antimicrobials. So let's discuss one by one. So, antibiotics. Okay. So, antibiotics comes from the word antibiosis. And this particular antibiosis means against life. So, against life. So, anti means against, bios means life. So, it is against life. But in practical sense, I will write down the definition today because you will remember the definition. It is substance derived from a microorganism. It is substance derived from microorganisms or produced synthetically, okay, to kill or suppress the growth of other microorganisms. The growth of other microorganisms. So I will highlight few key points in this definition. That is, it is a substance which is derived from microorganisms. So it is a substance which derives from microorganism and produced synthetically to kill. So it can kill the organism. So this is another keyword, and it can also suppress the organism. So it can also suppress their growth, rather killing it. So this is basically your what is called as antibiotics. So when we are into the world of antibiotics, when we are talking antibiotics in details, we should know the history of antibiotic, and that is very, very important. So I will discuss next the history of antibiotic. So if you get to see the history of antibiotics, so this particular image shows that a brief history of antibiotics and resistance. So I will start from the pre-20th century. In the pre-antibiotic age, it was common to die from minor infections. So there was minor infection. You know that this environment is a vast era of microorganisms, and out of it there are beneficial as well as pathogenic microorganisms. So minor infection is very common in an individual. So if there is no treatment option to inhibit their growth, then people will die. So at that time, people used to die. So then in 1910, the first antimicrobial drug, mind you, this is antimicrobial, it kills microorganisms of different spectrum. So the first antimicrobial drug, salvarsan, is synthesized from cloth dye and used to treat syphilis. So here I will highlight 2 points. That means it's a salvarsan, a chemical drug, which is being used to treat syphilis. Syphilis, I have talked to you in the last class that syphilis is a sexually transmitted disease caused by Treponema pallidum. And it is one of the very gravest disease because this organism grows inside the cell. So the antibiotic has to penetrate the cell to kill the organism. So that is why removal of the organism, killing of the organism is a bit difficult. Next, we will move on to your 1928. This is a remarkable year where Alexander Fleming discovered penicillin, being investigating its antibiotic potential. Now here I will just tell you a short story. You know that we know what is patent, intellectual property right. And according to US patent law, unobviousness of an experiment is a must to have a patent. So this was a great example of your unobviousness of an experiment. Why? Because Alexander Fleming was culturing Staphylococcus. So it was culturing Staphylococcus. So it's a yellow colored Staphylococcus, which are a confluent growth of Staphylococcus on the plate. Then all of a sudden, he saw one day that there was a green colored mold. So there was a green colored mold which is growing amidst the Staphylococcus, and that is very obvious because that can be contamination, right? But to his great astonishment, he saw that there was a zone of inhibition all around that particular mold. So there was a zone of inhibition all around that particular mold, and that was because of the growth inhibiting chemicals which is being produced by that green mold, and the green mold was your penicillium, and he named that. So the first penicillin was basically discovered, but he could not commercialize penicillin. Then in 1935, so I will move on to the next year, that is in 1935, sulfonamide drug are released and became the first antibiotic to be used systematically. So it was being given in intravenous form, the sulfonamide, and that was one of the antibiotic. But to tell you the truth, that sulfonamide was not as effective as penicillin, and so penicillin was a boon to the society, right? Now, from 1935, we will move on to 1941, where Ernest Chain and Howard Florey begin first clinical trials of penicillin, and they commercialized penicillin. So people get to use penicillin, right? So next, in 1943, so Allied World War II soldiers begin receiving supplies of antibiotics, saving thousands of lives. You know, because of this World War, there was wounds among the soldier, and because of the lack of medication, lack of antibiotics, they were dying exponentially because of the infection. So when this antibiotic came into being, it was supplied, and they started getting survived from the infection. So that was no doubt a boon. Next, in 1945, that was again a remarkable era where Nobel Prize awarded by Fleming, Florey and Chain for their work on antibiotics. So work on antibiotic was actually being given Nobel Prize. Then in 1948, penicillin-resistant Staphylococcus aureus became the global pandemic. So you know that this was once a boon, but it is by the human being, the human nature, right, who irrationally used the antibiotic, who basically abused the antibiotic, And that has led to the concentration of this antibiotic into the soil, into the water. And you know that when you give an organism stress, they will also know how to survive in that stress. So there came the emergence of your drug-resistant Staphylococcus aureus, and penicillin became inhibited. Penicillin could not work on Staphylococcus aureus. Now, in 1953, antibiotics are introduced to animal feed in Europe. Then we move on to 1959. So when there was the emergence of resistance, people started producing the derivative, that is methicillin antibiotics are invented to combat penicillin-resistant Staphylococcus aureus. So they started to combat penicillin-resistant Staphylococcus aureus by methicillin, right? Then in about 1960, so it is 1959, then after 1 year, 1960, the first strain of the methicillin-resistant Staphylococcus, MRSA, emerged. So again, due to the irrational use of the antibiotics and also the ability of the microorganism to manipulate themselves to survive in the stress condition, the MRSA emerged, the methicillin-resistant Staphylococcus aureus. And till date, scientists are researching on this particular organism because there are varied strains of this particular organism. Then in 1987, daptomycin is invented, and after this, no new class of antibiotics are discovered for 30 years, right? Then in 2014, British public vote for antibiotic resistant, right? So they started focusing on antibiotic resistance. They started understanding its importance and what could happen to this, to the society, to the environment, to the world, if they are not being curbed or if they are not being combated by various mechanisms. So then in 2015, the World Health Organization launched the first antibiotic awareness week. So the first antibiotic awareness week came into being. Then scientists produced improved form of teixobactin, a new class of antibiotic with the potential to destroy superbug. So here I want to stress on superbug. Now, superbug doesn't mean that it is a MDR, multi-drug resistant bacteria of superior quality. But superbugs are basically those organisms which is there everywhere, which is both beneficial and harmful. Like if you talk of Pseudomonas putida, which has been discovered by a genetically modified organism done by your Dr. Tamalika Chakraborty from the University of Illinois. So that is beneficial to the environment, soil degrading in nature. But on the other hand, the MDR is also a superbug. They are superior than other bacteria, right? And that particular organism is a threat. So that superbug was basically, so new antibiotics, people started researching on new antibiotics, new type of antibiotics, and I will also focus on certain recombinant antibiotics like hybrimycin was also being researched upon to combat antimicrobial resistance. To present day, individual researcher and policymakers are working together to fight antibiotics. So what is the take-home message from this history? The take-home message from this history is that this particular antibiotic was once a boon. But the irrational use of antibiotics, the abuse of antibiotics has resulted in the development of some of the deadliest pathogens which could not be treated by these antibiotics. So now even we have this so many discoveries, but this could not be fruitfully utilized because there is emergence of drug resistance. And so we have to research for new and new type of drugs, right? So the take-home message is that we should not irrationally use antibiotic. We should restrict antibiotic because we should know that when to use antibiotic and when to not, and always we use antibiotic under doctor's prescription. So next is your classification. So the classification I will be discussing in the next class. So classification I will discuss on various bases, like on the basis of your mode of action, okay, on the spectrum of activity, etc. So